Good morning students, Sairam. Let's continue with chapter 7 fractions. Children, in our previous session we learned how to add and subtract unlike fractions and also how to add and subtract mixed fractions. And also we solved two problems of exercise 7.6. In today's session we will continue to solve the problems of exercise 7.6. So, the problem number A and B of question 1 were solved in the last session. In today's session, we will continue with problem C. So, here we have two fractions 4 upon 9 and 2 upon 7 to be added. They are unlike fractions. So, what do? We find the LCM of the denominators and the fractions will be changed into equivalent fractions with the same denominator. But here we have two denominators which have 1 as the common factor. So, instead of finding the LCM, directly we can multiply the first fraction with 7 and the other fraction with 9. So, we have multiplied 4 by 9, 4 upon 9 by 7 and 2 upon 9, 2 upon 7 by 9. That means this fraction is multiplied by 7 and this fraction is multiplied by 9. So, it is the same as finding the LCM and then we get the equivalent fractions as 28 upon 63 and 18 upon 63 which we add. So, we retain the denominator 63 and add 28 and 18. What do we get? We get 46 upon 63. So, when we add 4 upon 9 plus 2 upon 7 we get 46 upon 63. Next problem 5 upon 7 plus 1 upon 3. Here also the denominators 7 and 3 are co-prime numbers. So, their LCM will be their product. So, we will multiply this fraction by 3 and this fraction by 7. So, we have done this and what do we get? We get 15 upon 21 plus 7 upon 21. Now, we can retain the denominator, the common denominator is 21 and add 15 and 7. So, what do we get? We get 22 upon 21. So, 5 upon 7 plus 1 upon 3 gives us 22 upon 21. Problem E. 2 upon 5 plus 1 upon 6. Here also 5 and 6 are having a common factor 1. So, this fraction we will multiply by 6. We will multiply by 6 and this fraction we will multiply by 5. This we have done. So, what do we get? We get 12 upon 30 plus 5 upon 30. Two equivalent fractions with same denominator. Now, we can add them easily. The denominator becomes 30, the common denominator, and we will add the numerators 12 and 5. What do we get? We get 17 upon 30. So, when we add 2 upon 5 and 1 upon 6, what do we get? We get 17 upon 30. Problem number F, 4 upon 5 plus 2 upon 3. So, again the same thing, we can just multiply the denominators to get the LCM. So, we will multiply 4 upon 5, we will multiply 4 upon 5 by 3 and 2 upon 3 by 5. This we have done here. So, what do we get? We get 12 upon 15 and 10 upon 15. Now, when we add the numerators and take the common denominator 15, what do we get? 12 plus 10 becomes 22 and the denominator is 15. So, we get 22 upon 15. So, 4 upon 5 plus 2 upon 3 is 22 upon 15. Problem G. Here we have a subtraction problem. 3 upon 4 minus 1 upon 3. So, here also 4 and 3 they have common factor 1. So, their LCM will be their product. So, what do? We multiply this fraction by 3 and this fraction by 4. 3 upon 4 is multiplied by 3 and 1 upon 3 is multiplied by 4. So, what do we get? We get 3 3s are 9 and 12. First fraction, equivalent fraction is 9 upon 12, and then we get here the sign should be negative sign. This is not a positive sign, it is negative sign. So, 9 upon 12 minus 4 upon 12. So, the common denominator is 12 and we subtract 4 from 9. What do we get? We get 5 upon 12. So, when we subtract 1 upon 3 from 3 upon 4, what do we get? We get 5 upon 12. The result is 5 upon 12. Next problem H, 5 upon 6 minus 1 upon 3. Here the LCM of 6 and 3 will be 6. So, we have to change both the fractions to equivalent fractions so that the denominator is 6. First fraction 5 upon 6 already has the denominator 6. So, we can multiply that with 1, and the fraction 1 upon 3 has to be multiplied by 2, the numerator and denominator both multiplied by 2 to get the denominator 6, the equivalent fraction with denominator 6. What do we get? We get 5 upon 6 minus 2 upon 6. So, 6 will be the common denominator and 2 will be subtracted from 5. 5 minus 2 upon 6, and we get 3 upon 6. 3 upon 6 can be reduced to the lowest form as 1 upon 2. So, 5 upon 6 minus 1 upon 3 is equal to 1 upon 2. Let us move on to the next problem. Here we have 3 fractions to be added, 3 unlike fractions to be added, 2 upon 3 plus 3 upon 4 plus 1 upon 2. So, what do? We find the LCM of 3, 4 and 2. So, the LCM is 12. Now, what do? We change each fraction into its equivalent form with the denominator 12. So, 2 upon 3 we multiply by 4 to get the equivalent fraction with denominator 12, and the next fraction 3 upon 4 we multiply both the numerator and denominator by 3, and the next fraction 1 upon 2 we multiply both the numerator and denominator by 6 to get the equivalent fraction with the denominator 12. So, what do we get? We get 8 upon 12 plus 9 upon 12 plus 6 upon 12. And when we add the numerators retaining the denominator, what do we get? We get 23 upon 12. So, 2 upon 3 plus 3 upon 4 plus 1 upon 2 is equal to 12 upon 3. 23 upon 12. Next problem. K, we have 2 mixed fractions to be added, 1 upon 3 plus 3 2 upon 3. So, what do? We first change the mixed fractions into improper fractions, and then we change them into like fractions and then we add them. So, how do we change them? We multiply the denominator and the whole number 3 and 1 and add the numerator 1 to it. So, what do we get? We get 4 upon 3, and the other fraction also 3 and 3 multiplied 9 we get, 9 plus 2 we get 11. So, we get 11 upon 3. Now, we have 2 fractions with the same denominators, they are like fractions. So, what do? We simply add the numerators and retain the denominator. What do we get? We get 15 upon 3, and 15 upon 3 can be reduced to the lowest form. 15 divided by 3 we get 5. So, when we add these 2 fractions, mixed fractions, what is the answer that we get? We get 5 as the answer. Next problem, 4 2 upon 3 plus 3 1 upon 4. So again we change the mixed fractions into equivalent fraction to improper fractions, and then we change them into like fractions, and then we add them. So changing these two fractions 4 2 upon 3 and 3 1 upon 4 into improper fractions, what do we get? We get 14 upon 3 and 13 upon 4. Now we find the LCM of 3 and 4, and that will be the denominator of both the fractions, and then change the fractions into equivalent fractions with the denominator 12. So 14 upon 3 will be multiplied by 4 and 13 upon 4 will be multiplied by 3. So we have done this here, and what do we get? We get the fraction 95 upon 12. By multiplying 14 by 4 we get 56, 13 by 3 we get 39, and the common denominator is 12, and then what do we get? By adding the numerators we get 95 upon 12 as the answer. So when we add these two fractions, mixed fractions 4 2 upon 3 and 3 1 upon 4, we get 95 upon 12 as the answer. Problem M, 16 upon 5 minus 7 upon 5. We have to subtract these two fractions, they are like fractions. Very simple, we have to retain the denominator and subtract the numerators. What do we get? 16 minus 7 becomes 9, and the denominator is 5. So we get 9 upon 5. Next, N, 4 upon 3 minus 1 upon 2. These are two unlike fractions. So what do? We can multiply this fraction by 2 and this fraction by 3 to get equivalent fractions with same denominator. So what do we get? We have done this here. We get 8 upon 6 minus 3 upon 6. Now when we 8 upon 6 minus 3 upon 6. So we retain the denominator and subtract the numerators. 8 minus 3 becomes 5 and the denominator is 6. So what do we get? We get 5 upon 6. So 4 upon 3 minus 1 upon 2 is equal to 5 upon 6. Now here we have a word problem. Sarita bought 2/5 meter of a ribbon and Lalita 3/4 meter of the ribbon. What is the total length of the ribbon they bought? So what we have to do to get the total length? We have to add both the fractions. Let's see how we do this. So length of ribbon bought by Sarita is 2 upon 5 meter and length of ribbon bought by Lalita is 3 upon 4 meter. So total length of ribbon bought by Sarita and Lalita is 2 upon 5 meter plus 3 upon 5 meter. So we have to add these two fractions. They are unlike fractions. So what do? Since 5 multiplied by 4 is the LCM. So first fraction we will multiply by 4 and this fraction we will multiply by 5. So we have done this here. What do we get? We get 8 upon 20 and 15 upon 20, which are the equivalent fractions of 2 upon 5 and 3 upon 4 with denominator 20. Now we have to retain the denominator and add the numerators. So what do we get? 8 plus 15, we get 23 and the denominator is 20. So what do we get? Total length of the ribbon as 23 upon 20. 23 upon 20 meter. Next problem. Naina was given 1.5 piece of cake and Najma was given 1/3 piece of cake. Find the total amount of cake that was given to both of them. So again we have to add both the fractions, but here we have mixed fractions. So first we have to change the mixed fractions into improper fractions and then change them into like fractions and then add them. So let's see how we solve this. Piece of cake given to Naina is 1 upon 2. So it becomes 3 upon 2, 2 ones are 2 plus 1 3 upon 2. And the piece of cake given to Najma 1 upon 3 means it is 4 upon 3. Now total amount of cake given to them is 3 upon 2 plus 4 upon 3, isn't it? But these two are unlike fractions. So we change them into like fractions by taking the LCM of the denominators. What do we get? It is 6. So we multiply this fraction by 3 and this fraction by 2 to get the equivalent fractions with same denominator. So we have done this here, and when we multiply this by 3 we get 9 upon 6, and here this one we get 4 upon 3 becomes 8 upon 6. Now we retain the denominator and add the numerators. What do we get? We get 17 upon 6. 17 upon 6 is an improper fraction. It can be converted into a mixed fraction. So what do we get? We get 2 5 upon 6. So the total amount of cake that was given to both is 2 5 upon 6. Coming to the next problem. Question number 4, fill in the blanks. A dash minus 5 upon 8 is equal to 1 upon 4. So we have to fill in the box here. So missing number is 1 upon 4 more than 5 upon 8, isn't it? Because 5 upon 8, when we are subtracting from this missing fraction, we are getting 1 upon 4. So how do we get the missing fraction? We add these two fractions, 1 upon 4 and 5 upon 8, to get the missing fraction. So we have done this. 5 upon 8 plus 1 upon 4, it becomes 7 upon 8. Alright, and we get 7 upon 8 as the fraction which has to be filled in the box, because the LCM of 8 and 4 is 8. Next is 1 upon 2 minus dash is equal to 1 upon 6. So what has to be subtracted from 1 upon 2 so that we get, what has to be subtracted from 1 upon 2 so that we get 1 upon 6. So the missing number is 1 6 less than 1 upon 2, isn't it? So what do? We subtract 1 upon 6 from 1 upon 2 to get the missing fraction. So here we have 2 and 6, we find the LCM, it is 6. So first fraction will be multiplied by 3 and the next fraction has 6 as the denominator, so we don't have to change it. So what do we get? We get 3 upon 6 minus 1 upon 6, and the result is 2 upon 6. 2 upon 6 can be reduced to the lowest form, that is 1 upon 3. So what will be filled in the box? It is 1 upon 3. So the missing fraction is 1 upon 3. When we subtract 1 upon 3 from 1 upon 2, we get 1 upon 6. Now here we have to complete this addition subtraction box. Towards right we have to add, and towards down we have to subtract. So when we add these two fractions, what do we get? That we will write here, and when we add these two fractions, what we get? We write here, and when we subtract this fraction from this one from this, we get what we get, we write here, and we subtract these two fractions and write the answer here. Let's see how we do this. So first row will be addition, isn't it? First row is addition, 1 upon 2 plus 1 upon 3. So the common denominator becomes 6, the LCM of 2 and 3, and what do we get? We get 3 plus 2 upon 6 and the result is 5 upon 6. So, 5 upon 6 is filled here. In the second row we have 1 upon 3 and 1 upon 4. So, when we add 1 upon 3 and 1 upon 4, we take the LCM of 3 and 4, which becomes 12, and then we change both the fractions into equivalent fractions with 12 as the denominator, and then we add the numerators. So, what do we get? We get 4 plus 3 upon 12, and 4 plus 3 becomes 7 and the denominator is 12. So, 7 upon 12 is the fraction that we get by adding 1 upon 3 and 1 upon 4. So, this is the result. Now, we have to subtract the fractions given in the columns, that means here. So, we have to subtract 1 upon 3 from 1 upon 2. So, 1 upon 2 minus 1 upon 3. So, here also what do? We find the LCM of denominators, that is 6, and then change the fractions into equivalent fractions with denominator 6. So, by doing this what do we get? We get 3 minus 2 upon 6 and the result is 1 upon 6. So, this box will be filled by 1 upon 6. In the second column we have to subtract 1 upon 4 from 1 upon 3. That means 1 upon 3 minus 1 upon 4. Again, for the denominator, common denominator, we find the LCM of 3 and 4, which becomes 12, and we subtract the numerators after changing the fractions into equivalent fractions with denominator 12. So, what do we get? We get 4 minus 3 upon 12. That means it becomes 1 upon 12. So, the second column is filled by 1 upon 12. Now, what we do? We can add these two to get this 1 upon 4, or we can subtract these two. That means 5 upon 6 minus 7 upon 12 to get 1 upon 4, or we can add 1 upon 6 and 1 upon 12, then also we get the result 1 upon 4. Problem number 6. A piece of wire 7 upon 8 meter long broke into two pieces. One piece was 1 upon 4 meter long. How long is the other piece? So, we have a wire, suppose this is the wire which is of length 7 upon 8. Okay, it broke into two pieces. One piece was 1 upon 4. Suppose this piece is 1 upon 4. So, what is the length of the other piece? So, what do? We subtract this fraction from this fraction to get the length of the remaining piece. So, let us see how we do this. So, total length of the wire is 7 upon 8 meter, and the length of the piece of wire which broke, it is 1 upon 4 meter. So, what will be the length of the other piece? It will be 7 upon 8 minus 1 upon 4. Now, what is the LCM of 8 and 4? It is 8. Now, we change both the fractions into equivalent fractions with denominator 8. Now, 7 upon 8 is already having denominator 8. So, we do not change it. 1 upon 4 we change into an equivalent fraction by multiplying both the denominator and the numerator by 2. So, what do we get? We get 2 upon 8. So, next step, we retain the denominator and subtract the numerators. So, 7 minus 2 upon 8. And what will be the answer that we get? We get 5 upon 8 as the answer. So, the length of other piece will be 5 upon 8 meter. Next problem. Problem 7. Nandini's house is 9/10 kilometer from her school. She walked some distance and then took a bus for 1 upon 2 kilometer, that means half kilometer, to reach the school. how far did she walk. So, the total length is given of Nandini's house from Nandini's house to her school is 9 upon 10 kilometers. She walked some distance and took bus for 1 upon 2 kilometers. So, how much distance she walked, that we have to find out. So, we have to subtract 1 upon 2 from 9 upon 10. Let us see how we do this. So, total distance from school to house is 9 upon 10 kilometers, and the distance travelled by Nandini by bus is half kilometer or 1 upon 2 kilometer. So, the distance travelled by her on foot will be the difference between the two distances, okay, the 1 upon 2 kilometer subtracted from 9 upon 10 kilometer. So, it is 9 upon 10 minus 1 upon 2. And how do we subtract these fractions? We find the LCM of 10 and 2, that is 10, okay, and then we change both the fractions into equivalent fractions with denominator 10. So, 9 upon 10 already it has the denominator 10, we have to change this fraction so that it gives us an equivalent fraction with denominator 10. So, this we have done. 1 upon 2 is multiplied by 5. Now, we get two like fractions, 9 upon 10 and 5 upon 10. So, 9 upon 10 minus 5 upon 10 kilometers. So, we retain the denominator and subtract the numerators. What do we get? We get 4 upon 10 kilometers. That means, when reduced to lowest form, it gives us 2 upon 5 kilometers. So, the distance travelled by her on foot is 2 upon 5 kilometers. So, here from the total distance, we have to subtract the distance travelled by bus. So, we get the distance travelled by foot. So, this distance travelled by foot is 2 upon 5 kilometer. Next question. Asha and Samuel have bookshelves of same size partly filled with books. Asha's shelf is 5/6 full and Samuel's shelf is 2/5 full. Whose bookshelf is more full and by what fraction? Let us see how we solve this. So, Asha's shelf is full by what fraction? 5 upon 6, and Samuel's shelf is 2 upon 5th full. Now, we have to compare these fractions. How do we compare them? We find the LCM, make them like fractions, we will change them into like fractions and then we can compare them. So, what will be the LCM of 6 and 5? It will be 30, isn't it? So, we change both the fractions into equivalent fractions with denominator 30. So, we get 5 upon 6, when we change we get 25 upon 30 and 2 upon 5 becomes equivalent fraction 12 upon 30. Now, we can compare these fractions. Now, 25 upon 30 and 12 upon 30. Which one is greater? Since 25 is greater than 12, so 25 upon 30 is greater than 12 upon 30. That means the fraction 5 upon 6 is more than 2 upon 5. That means whose shelf is more full? It is Asha's shelf which is more full than Samuel's shelf. Now, we have to find how much more. That means we have to subtract the fraction of Samuel's shelf from Asha's shelf. So, 5 upon 6 minus 2 upon 5. Again, we find the LCM. We have already done that. So, 25 upon 30 is the equivalent fraction of 5 upon 6 and 12 upon 30 is the equivalent fraction of 2 upon 5 with denominator 30. Now, we can subtract them. So, 25 minus 12 becomes 13 and the denominator is 30. So, what is the fraction which is more full of Asha's shelf? It is 13 upon 30. So, this is the way we solve this kind of problems. Next, children, with this problem we come to the end of exercise 7.6 and the chapter fractions is also over. Children, you take a pen and notebook and note down all the problems those are solved, and also you practice them again so that you learn the addition and subtraction of fractions properly. Thank you.